Let's go fly a kite up to the highest height for geometry 6-6 trapezoids and kites. A quadrilateral with exactly one pair of parallel sides is called a trapezoid. So these two, the two bases, are parallel. The other two are called legs. So the parallel sides are bases. The other two, the non-parallel ones, are called legs. The base angles are formed by the base and one of the legs. And if the legs are congruent, then we call that an isosceles trapezoid. In isosceles trapezoids, they have particular qualities. So, for example, each pair of base angles is congruent. So these two angles of the base are congruent, and on the other base, those two angles are congruent. That's 621. And on the other hand, 622 says if it has one pair, if a trapezoid has one pair of congruent base angles, then it is isosceles. Next, a trapezoid is isosceles if and only if its diagonals are congruent. Okay, so in an isosceles trapezoid, the diagonals are congruent, are the same length. Alright, to use what we know, we have this speaker. It is an isosceles trapezoid if FJH, if this angle is 85, and FK, this length, is 8, and J to G, this diagonal, is 19. Find each measure. Okay, let's start with measure FGH. If we're looking for this measure right here, we know in an isosceles trapezoid that the base angles are congruent. So we know this one is also 85. And then we know together all of these make 360. We also know that F and G, those angles, are the same measure, so we can call those just 2 times this measure, 2 times x. And then solving, subtract the 170 from down here, from 360, and we get 2x is 190, so each one of these measures is 95 degrees. So measure FGH is 95 degrees. If I want to find the length of KH, well, I know that this diagonal is 19 inches, and these two diagonals are the same length. So that means that FH is also 19 inches. And together, FK to KH gives me 19 inches, or is the same length as JG. So then we substitute 8 in and subtract 8. We find that KH is 11 inches. All right, mid-segment of a trapezoid. That is the segment that connects the midpoints of the legs. Okay, so the mid-segment is parallel to the bases. And also its measure is the average of the two bases. So if you add the two bases together and divide by 2, then that is the measure of the mid-segment. A kite, if a quadrilateral is a kite, then the diagonals are perpendicular. Diagonals are at a right angle to each other. And if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Okay, and notice adjacent sides are congruent. So, here we go. Using the properties of kites, if this is a kite, FGHJ, then we want to find GFJ. We want to find this angle right here at F. Well, we know these two angles together, added together, subtracted from 360, give us these two, and we know that F and H are the same measure. So we can group F and H together and say that's angle X, 2 times angle X, plus the other two angles together gives me 360, subtract from 360, and X is 80. So we know that this measure is 80 degrees, if I want to find a length, so from z to y, then I can use Pythagorean theorem, because I know there's a right angle with the diagonals. So I have 8 here, pz, and py. A squared plus b squared equals c squared. And c is the longest side. So solve that, Pythagorean theorem. We know that zy squared is 640. Remember to square root it. There's nothing to it. To find the measure of the longest side. And there you have it, ladies and gentlemen. That's it for today. Chapter 6, Lesson 6, Trapezoids and Kites. Remember to like and subscribe, and hit that notification bell to become part of the notification squad.